Default gateway. What is default gateway? What is default gateway? And why do we require default gateway?
Entrance point
Entrance point.
for different network.
Okay. Is it entrance point or exit point? Both. Okay.
Router can reach the destination. Exit point.
Exit point. What about the entrance point? See, why do you require a default gateway in your network? Whenever you want to communicate with some other network, right? Let's say right now we are in this classroom. Okay, consider we are part of this classroom. Okay, so whenever the students who are present inside the classroom, they want to communicate, are they going to require to pass through this gate? Do they require to pass through this gate? No. Why? They want internal communication. So they do not require any sort of gate. Right now, you guys are sitting in this classroom. So do you require this gate for communicating? No, you do not require. But whenever you want to communicate with the students who are in the nearby classroom, then you have to exit through this gate. Then you will go and communicate, right? So your default gateway is nothing but the exit point of your network. It is the IP address of your network through which your traffic is going to exit your network. And usually whenever the traffic has to exit from your network, will be exiting through the router, because router is responsible for communication between different networks. So if we say what will be the default gateway IP address, that will be the IP address of your router, because your router is the responsible device for exiting the traffic from one network to another network, or from transferring the traffic, forwarding the traffic from one network to another network. Okay. So why do we require default gateway? For communication between different networks. Is that clear? Okay. Okay. So if you see, okay, let me complete this. And this is your ISP. Or if you do not want to consider ISP, in that case, what we can have, see, ISP is one of the examples, but not necessary that always the ISP will be there. In case if you want to communicate with any different network, means even in your company also, if you have multiple different networks. Okay, let's say you have one more department, there's one more switch available. And they are connected like this. Okay, fine. Okay, consider it. So if these two networks wants to communicate, then they will require a default gateway. Okay. So if we say this is your router, and then this is our switch. Switch one. switch to. Okay, let's consider here the IP is 10.1. This side the IP is 20.1. Okay. So here we are using 10.1.1.0/24. The other side we are using /20. Okay. So in these PCs, the gateway will be 10.1, right? Because they belong to the 10 network. So here the gateway will be 10.1, and here the gateway will be 20.1. Okay, the gateway will be always in the same network only, will not be in the different network. For 10 network, the gateway cannot be 20.1, and for 20 network, the gateway cannot be 10.1. It will be from the same network itself. Okay. Why it cannot be in the different network? Why gateway cannot be in the different network? Because for different network communication itself, we need the default gateway. So if the default gateway is already in the different network, then there is no possible communication. Okay. Now, right now, we are sitting in this classroom. Okay, but your gate is in some other classroom, then how you are going to exit this room? Right? Let's say this gate is not there, but the gate is with the nearby classroom. Right? Means in a different network. So how you will be able to exit this? How you will be able to exit this classroom? Okay. So that's why your default gateway has to be in the same network. Okay. Now, when we have this concept of default gateway and multi-network communication, okay, in that case, what is going to happen? There is a new type of ARP going to generate, and that ARP is known as Proxy ARP. Okay. Now, why Proxy ARP? So what will happen? See, consider this scenario when we have this PC, let's say having the IP 10.2, 10.3. This is having 20.2, 20.3, 20.4. Okay. Then MAC addresses, let's say M1, M2, M3, M4, M5, M6, and M7. These are the MAC addresses. Now let's say you go to the PC. This is PC1, PC2, PC3, PC4, and PC5. So let's say you go to the PC2 and give the command ping 20.0.0.2. Correct? What will happen? ICMP packet will be generated. When the ICMP packet will be generated, this is ICMP. In the ICMP, there will be information source IP, destination IP, source MAC, destination MAC. Right? Source IP will be 10.0.0.2 because PC1 is generating the traffic. Who is the destination? Because we have given in the command. Source MAC, PC1 knows its own MAC address. Destination MAC, it will check in the ARP cache, and initially it will not be available. Means this information is missing. If this information is missing, this packet will remain on hold. Then what will happen? A new packet will be generated. What will be generated? ARP. If the ARP will be generated, source IP, destination IP, source MAC, and destination MAC. Source IP will be 10.0.0.2, destination, source MAC, destination MAC, broadcast, right? Because our ARP is encapsulated inside the Ethernet. So in the Ethernet header, destination MAC will be all F. But if you consider the specifically ARP header, then it will be 0. 0 means unknown. Okay. Now this will travel. Since this is a broadcast packet, so whenever a switch receives a broadcast message, what your switch is going to do? Forward it everywhere. means forward it this side as well as this side. Now this message reaches to the router. Will your router forward this broadcast message on the other interface? No. Why? Because your router has per port broadcast domain. So it will not forward. Plus your ARP, or this is ARP, right? And ARP is a layer 2 protocol. Router is a layer 3 device. Correct? So will not forward. So if it will not forward, are we going to get the MAC address anyhow? No. So if we will not get the MAC address, we will be able, are we going to able to be communicate? No, we will not be able to communicate, right? But still we have different network communication. How that is happening? What your router is doing? Your router is responding to this ARP request. To this ARP request, your router is responding saying that, okay, I am 20002 and my MAC address is M6. Means instead of giving the MAC address for PC, actual PC, your router is acting on the behalf of this PC. And whenever someone is acting on the behalf, that is known as proxy. Like in the college classrooms, we used to do, our friend is absent. Still, if the teacher is announcing the name, yes, sir, present. That is what? Proxy. Same way, here, instead of direct going the communication happening through the PC, getting the MAC address of the PC, your router will respond and will give its own MAC address. Since your router will give its own MAC address, this response will be known as proxy ARP. Okay, only this response is known as the proxy ARP. Is that clear? How this is happening? Now there are two cases. What are these cases?
Sir, I don't understand the router by advertising the computer 002 ID.
Because otherwise communication will not be possible. See,
Router can-
let's say a router will not advertise. Now tell me your case.
Router can advertise if people get 10.0.0.1 and if no, now back at FM6.
But who is the destination here? For whom this packet is going? 20, right? And router forwards the packet based on the IP address. So is it router's IP address? No. Okay. So router, instead of advertising 20.0.0.2, router will say, I am 20.0.0.2. Because if somehow we are not getting the MAC address entry for this IP, we will not be able to communicate. Your packets will drop due to encapsulation failure. Okay, whenever you are asked that when you try to ping in different network, your first packet drops. Why? You will say encapsulation failure. Then if further you are asked why encapsulation failure, because the source will not have the MAC address of the destination and the ARP process is going to take place. So due to that reason, there will be encapsulation failure, and due to the encapsulation failure, your first packet of the ping is going to drop. Is that clear? Okay. Now, what are the two cases here? See, first case, when your host are a PC, computer. In that case, what will happen? In that case, whenever you want to communicate with a different network, whether that be any network, always in the ARP and everything, your destination will be your gateway. In that case, always your destination, what it will be? Your gateway. Because in the PC, we will provide default gateway. So it will generate the ARP for default gateway. First thing, in case of PCs. Now, you'll say, if it is generating the ARP for default gateway, then router will be advertising that, okay, I am 10.0.0.1. Okay. And then this is my MAC address. So this is normal ARP and normal ARP request and response. Why do we call it proxy ARP? It will be known as proxy ARP in the case when you are having multiple routers. When you have multiple routers. Means, for example, in case if you are using router in the place of PCs, if we use the routers, in that case, what will happen? Your ARP will be generated for the destination only. Your destination will be destination IP only. I'll show you both the cases. I'll show you with the practical itself, so you'll understand. Okay, when there is router, see, when there is PC, it will generate for default gateway. That's why we provide the default gateway. That okay, anything coming, we'll just talk to the default gateway, and default gateway is responsible. Like if I show you as of now, in my PC, I will give that default gateway as my router IP. Now, whenever I want to go to the internet, doesn't matter where I want to go, Google, YouTube, any IP address, any website, still I'm able to go. Why? Because I'm saying that to any network I want to go, I'll send my traffic to my router. Now, my router knows everything. I don't know. This is what the default gateway is. Okay. But when you have the router, in that case, the ARP will be generated for your destination IP, and there you will clearly see that your router is behaving as a proxy. Okay. So now let me show you Proxy ARP. Practically, you will understand. Packet tracer, everyone has downloaded and installed. Any doubts with the comments or something? No. Okay. See, first case I'll show you when we use PCs. Now let me directly use two PCs only without the switch. This side will use the network 10.1.1.0/24. This side will use 11.1.1.0/10. Okay. On the router, IP will be 11.1. Here it will be 10.1. Here the IP address will be 10.1.1.2. Here it will be 11.1.1.2. Okay, let me select these also. Okay, these will be the IP addresses. Desktop IP configuration 10.1.1.1 255.255.
Yes,
Yes. Okay, default gateway will be 10.1.1. Okay. And for easy understanding, let me do one thing. Let me change the MAC address. Okay, here I will change the MAC address. For PC1, all zeros and 1. For PC2, all zeros and 2. Okay, this is just for the explanation purpose. In the real scenarios, you will not be able to change. Because MAC address is a physical entity. Desktop IP configuration 11.1.1.2 11.1.1.1, and here we'll make it all zeros and 2. Okay, so that when we check the packet, we can understand that what is happening. Okay. Okay, we have assigned the IP addresses to the PCs. Now we need to assign the IP addresses to the router. Okay, let's do one thing for router also. Let's change the MAC addresses so that we can understand which interface IP address it is giving. So this side we have 10 networks. So I'll make it all zeros and 10. Here all zeros and 11. This side 10. And on the Z0 by 1 side 11. Even with command also you can change in the router. Okay. See, if you want to change it with the commands, you can simply go to the interface and give the command MAC address and whatever the MAC address you want to assign. Okay. Now see. Now you'll say MAC address cannot be changed and we have changed the MAC address in the router. Is that even possible? So this is just a temporary entry, not a physical. Okay, if you want to see this interface, you can give the command show interface Z0 by 0. Let's say this one. Okay. If you hit enter, you'll see that it is saying that the MAC address is what? This, but this is the physical address. That is also known as burned in address, BIE. Okay. This thing you cannot change. This temporary entry, what you want to use, that you can change in the router, but your burned in address, your physical entry, you cannot change because this is fixed with the NIC. Okay. All right. So now we will understand. First of all, let's go and assign the IP addresses. So let me answer. Okay, tell me the comments. Enable. Okay. Okay. IP address. No shutdown. Now even you can use upper arrow keys and just edit the command for the new interface. Okay. This will make it easy for you to configure. You don't have to type commands every time. Okay. This is done. Now check. I'll go to the simulation mode and see. Right now by default it will show you all the different protocols. But right now if we see, we just want two protocols. One is the ARP and second is the ICMP. Correct? So you can click on show all none. Everything will be cleared. Edit filters. Now one is ICMP I want to see and one is ARP I want to see. Nothing else I want to see. Because see, right now there is a no switch, so no extra packets will be there. But if there is a switch, there will be lots of STP packets and all. So they might create confusion. Okay, so you can just certainly filter out what all the packets you want to inspect or see. Okay. Just go to the PC, desktop, command prompt. Now see. If I say ping 11.1.1.2, hit enter. Two packets will be generated. One will be ICMP, second will be ARP. ICMP, ARP. In ICMP, Ethernet address will not be present, so we have the ARP. Now, if I open the ARP, you see what is the destination here? 10.1.1.1. Now, why the destination is 10.1.1.1? Check that. Because this is the default behavior of your PC. If you read, the ping process starts the next ping request. The ping process creates ICMP echo request message and send it to the lower process. The source IP is not specified. The device sets it to the port's IP address. So what is on the port of this PC? What is the IP address? 10.1.1.2. So source IP is set. The destination IP address 11.1.1.2 is not in the same subnet and is not the broadcast address also, right? The default gateway is set. The device set the next hop to the default gateway. Now, since the default gateway is set, The next stop IP address is a unicast IP address. And next stop, what did they set? Default gateway. If you see here, default gateway set, the device set the next stop to the default gateway. The next stop IP address is a unicast, so the ARP process look it up in the ARP table. The next stop address is not in the ARP table. The process tries to send the ARP request for the IP address and buffer this packet. Now what will happen? This packet has been generated for the next stop. So your green packet will travel first. Done. Now your router will respond. So when your router will respond, this will be response from the 10.1.1.1 to 10.1.1.2. So you'll say this is normal ARP request, right? Why? Because we are using here what? PC. Okay. So in case of PC, what happens whenever we want to communicate with a different network? This is always the case that we always send our traffic to the default gateway. We do not care about the MAC address of the destination. This is the behavior of PC. But the behavior of router is that they want the MAC address of each and every IP address they are able to reach. Okay, they want to reach. In that case, you will see the proxy ARP. So right now, this is normal ARP. Okay. Now this will respond, then the ICMP packet will start. So as soon as this will respond, do your router has the MAC address for 11.1.1.2? Let's check. Initially, will your router is your router going to have the MAC address? If I say show ARP, see. The ARP entry came from 10.1.1.2 to the router. So router has one entry for 10.1.1.2. And these two IP addresses, these are for the router itself. So router has their own MAC addresses. See, we set the 10 and 11 and has an entry for your PC1. But does it have an entry for PC2? No. So this ARP request came up looking for this gateway. Router will respond with this information. But when the ICMP was generated, in the ICMP, what was the destination? 11. So means according to PC, the information of the gateway will complete and it will send up the ICMP. The router will receive the ICMP packet. Source IP. Destination IP 11.1.1.2. Okay. Then source MAC will be all zeros and one, like 0001, and destination MAC 00, not 2, 10, because it was sent for the here. Okay. Then what will happen? Router will check what is the destination. Router doesn't care about the MAC addresses. Router will just check what? IP addresses. It will check where it wants to go. 11.1.1.2. Now, when router wants to generate a packet, router will also need the MAC addresses to complete the information of the packets. Is there any entry for 11.1.1.2? No. So means router will again generate what? ARP. So there will be one more ARP request from here till here, and it will respond. And what will happen to this ICMP packet? This will drop. No. Now this time it will not hold. This will drop. And this is the reason your first ICMP packet drops, because here it will be encapsulation failure. And since there is encapsulation failure, the packet will drop. It will not drop on the PC, but will drop on the router. Is that clear? Now see each and every request and response, I'll show you. So far, we came to know that your PC1 sent the request to the ARP request to the gateway. Now gateway will respond with the MAC address. As soon as gateway responded with the MAC address, your ICMP packet got generated, which one was on hold. So if you see from where it is going, all 001 means from PC1 going to
10.
router. But if you see the source IP and destination IP, what is the source IP?
100
What is the destination IP?
11.1.
But for this IP, Is it the correct MAC address? No. This is another reason we call it as a proxy ARP. Because the IP is something else, but the MAC address is for router. This is another reason we call it a proxy ARP. Okay. Now you'll see router doesn't have the MAC address for 11.1.1.2. We have checked here. For router, we have checked that okay, your router is not having. See, no entry for 11.1.1.2. So this packet will go to the router. What happened? This packet got dropped. Why? Encapsulation failure. And at the same time, router generated what? ARP. Why? You see, from going from 11.1.1.1 to destination, because router doesn't have the MAC address for destination. Okay. And if you see why this packet got dropped, see, the routing table finds an entry to the destination IP address. The destination network is directly connected. The device set the next hop. Then the device decrements the TTL, because see, like I said, the TTL value, if you remember, that every time router forwards a packet, the TTL value will be decremented by 1. Did I say it or not? In your class? Maybe some other class. Okay, no problem. Now see, why packet got dropped? The next hop IP address is not in the ARP table. The ARP process tries to send the ARP request for that IP address and drop the packet, because the next hop address is not in the ARP table. Means router doesn't have the ARP entry. So router will not send this packet, will drop the packet because of encapsulation failure. Is that clear? Okay. Now this first packet got dropped, and this side the ARP process will take up the problem. Request, response. Done. Now router has the MAC address. We can check. Now router has the MAC address for log. So the first packet this side got dropped. Okay, you'll see. And this is the second packet. So first packet was request timed out, because router did not respond to the request. And now when this packet will go to the router, source is, destination is, source MAC will be PC, destination MAC will be your router. Okay. Now what your router is going to do here, you'll see that source IP and destination IP will remain same, but router will change the MAC addresses. Source will become 11 and destination will become 2. Means, so in the source MAC, router will give its own MAC address, and in the destination, router will give the other MAC address. But the source IP and destination IP will remain the same. It is from 10.1.1.2 to the 11.1.1.2. Right now, it is from PC1 to router. Now see. This information, layer 3 information, compare it. Same. Layer 3 information, source IP 10.1.1.2, 10.1.1.2. Destination IP 11.1.1.2, 11.1.1.2. But if you check the layer 2 information from PC1 to router, but what is happening here? Router to PC. You see, router is making some manipulations in the bit, right? Went to the PC. Now, when this PC will respond, again, the IP information will always remain the same. See, earlier when the packet arrived, source was 10, destination was 11. Here, source will be 11, destination will be 10. Okay. From PC2 to router. Now, when this packet will go to the router, router will again change the MAC addresses. See, earlier PC2 router, and now what? router to PC1. So router is acting as a proxy in between, making some manipulations. Okay, telling them, okay, I'm to PC2, it is telling, okay, I am PC1, and to PC1, it is telling, okay, I'm PC2. These are my MAC addresses. So this is why we know it as a proxy ARP. This is one reason. But still, if it is not clearly understandable, let's do one thing. At the same time, we will use two routers, and there you will be able to see. Right now, if you see the entries in the PCC, if I say ARP -8, so I will have only one entry for my default gateway. I will not have any entry for 11.1.1.2. See why? Let's say, for example, in the real scenario, let me tell you. See, if I ping right now, first of all, let me show you my ARP cache. Okay, so this is my ARP cache. Okay, so this is first entry for my router, first IP 17.1.1. This is my default gateway, my router. Then this is from some other PC. This is my broadcast address, and these are some multicast addresses. Okay, only these entries I have as of now. Now let me try to ping google.com. Ping google.com. I ping Google. This is the IP address of Google. Let's see if I have the MAC address for Google now. Do I have it? No. Why? Because if I start making MAC address entry for each and every IP address I communicate, you can imagine how many websites we visit a day. Whenever we are visiting one website, we get, you can say, forwarded to or redirected to multiple different websites. So how use will be the MAC address table of our system? So for that purpose, your system will always just focus on the default gateway. So any traffic, send it to default gateway. We do not care. Now your default gateway is responsible. Okay. And your proxy ARP, it helps to reduce the size of MAC address table. Why? Because only we have one entry for our default gateway. Otherwise, if you will have entries for each and every website, you can imagine how much. Let's say right now I'm pinging Google, right? Then I can say ping Twitter, right? Then I can say ping Facebook. So like this, you see multiple different IP addresses will be there. And for each and every IP, if I will have the MAC address entry, this will be used. Is that clear? Okay. Now, usually here you will not be able to see whether the router is acting as a proxy or not. Means maybe you might have some confusion here. Okay. But when you will see in case of routers, okay. Let me do one thing. Instead of PCs, I'll be using routers. You know, your router also you can use as a PC. Means in just packet tracer, okay, not in the real scenarios. Because in the router, you cannot install Windows and use it. But just for the practice purpose, we can use it here. See, like I said, your router and PC are considered as same devices, right? So if you disable the routing feature of your router, that will just behave like a host only. Okay. So how do you disable? Let's see. Okay, these are all again same IPs and everything. Do we have the IP addresses? So on this router, IP addresses are already configured. On these two routers, we need to configure. Let me configure. So let's say this router, I'll call it as a okay, let me delete this. Again, let's consider this is your PC1. This is your PC2. No. Enable configuration terminal. First of all, I'll change the host name. Let's say I'll call it as a PC1. Interface Z0 by 0 and MAC address I'll change so that we will be able to understand that PC1 will have the MAC address, all zeros and 1. Okay. IP address 10.1.1.2, 255.255.255.0. No shutdown. This is done. Here on the PC2, no enable configuration terminal, interface Z0 by 0, MAC address. Okay, this is just I'm changing for the explanation purpose only. 11.1.1.2, 255.255.255.0, and no shut. Host name is. Okay, now it is correct. Let's check ARP cache. Show ARP. Only one entry. For what IP address? (11.1.1.2) self IP, right? What about this one? We'll also have one entry for self. Sure. Correct. What about the router? Sure. What happened? Do sure. Correct. Why do sure? Global configuration mode. Whenever we want to use a privilege mode command in the global configuration mode, we append do. Only 2 entries for the self IPs. No entry for 10.1.1.2. No entry for 11.1.1.1. And see, MAC addresses are a little bit different. So let's change these also. Interface Z0 by 0. MAC address. Now let's check. Why error? Sure. Okay. So now everything is correct. For 10 network, we have the 10. For 11 network, we have the 11. Okay. Now focus. Now you will clearly see the ARP. Now sometimes you will run in this problem also. Okay. That you will type something wrong and your router will start translating this domain server. Okay. So there is a escape sequence. Control Shift 6. Sometimes it will work, sometimes it will not work in the router. Okay. If it doesn't work, what you can do in the packet tracer, either wait for a long time, means like 2 minutes, or else you can just, you have this fast forward button, press it 1 or 2 times, done. Okay. Now see, I'll say what thing. And before that, let me go to the simulation mode. and we want to inspect only ARP and ICMP. This one, let's clear as of now. Okay. I'll say ping 11.1.1.2. What is generated? Packets generated. Direct ICMP. I think due to this packet, see, due to this error, it already got the MAC address. Okay, let's check. Does it already have the MAC address here? IP packet is there, ICMP is there. Source IP. We didn't configure the IP on the router's IP.
Default with
No. These routers. That didn't happen. Route is not there actually. Route is not there. See, we have to make this router behave as a PC, because if it will be acting as a router, it will need a route to communicate with different network. So simple, in the global configuration command, give the command no IP routing, and it will start behaving as a PC. In the global configuration mode, give the command no IP routing, and it will start behaving as a PC. Now, if it is behaving as a PC, it is going to require a default gateway also. So the command is IP default gateway. And what will be the default gateway? 10.1.1.1 for this PC1. Correct? Similarly, on PC2 also we have to do the same thing. Go to the global configuration mode, say no IP routing to disable the routing features, and then apply the default gateway, IP default gateway, and then given 11.1.1. This is clear. Now you'll clearly see. Go back to simulation. First of all, check, do show ARP. Do we have ARP entries? We do not have, right? Now we'll try to ping. If I'll say do ping 11.1.1.2, 2 packets are generated. One will be the ICMP, second will be the ARP. Now see, ARP is there, source is, destination is, source MAC is 1, destination is F, correct? Okay. Now, according to the destination IP address, where these packets should reach? Here. Okay. And who should respond to this ARP? This. But when this ARP packet will reach your router, will this router forward the broadcast message from one interface to another interface? No. Instead, what your router is going to do here, you see here. This is ARP request from 10.1.1.2 to 11.1.1.2. The MAC address is from PC1 to broadcast. Now, here what is happening? What is the source IP? Source IP is, do you clearly see now that this packet is not even here and there is already a response? From where? PC to IP. To whom? PC1. From source MAC, router, and destination MAC. Now you can clearly say your router is acting as a proxy. Means this packet is for this PC, but he is saying no, I am this PC and take this MAC address. Okay. Now you see this packet will not even come this side and it will go back here. Now, since this information is complete, this will generate new ICMP. Correct. But now your router also has some knowledge that someone is looking for 11.1.1.2, right? So means I need MAC address for 11.1.1.2. So this is the ICMP packet. See the ICMP packet from PC1 to PC2. MAC address from PC1 to router. Okay. As soon as this packet will reach the router, it will drop this message. Why? Does not have the MAC address for PC2. And at the same time, it will generate a ARP from where? Router to PC2. It will try to know the MAC address for PC2. So this is simple ARP request and response, because this is from router to PC and PC will respond to the router. There is nothing special here, right? So this will normally complete. If you check in this PC as of now, do show up only 2 entries. Only 2 entries for 11, 1 and 2, means PC and router. Still, this PC doesn't have the MAC address for PC1. Okay. Now, new ICMP will be generated here because it is sending 4 packets, right? This is the second packet. Will go here. See, according to this, this has all the entries. This router has all the entries that, okay, I'm going to go from PC1 to PC2. This is source MAC and this is destination MAC. Correct? Forward to the router. Does your router have the MAC address for PC2? Have it? Okay, done. But does your PC2 has the MAC address for PC1? No. Again, encapsulation failure. Correct? ARP is generated. From where the ARP is going? PC2 to PC1. Source is PC2, destination is broadcast. Now again your router will act as a proxy. To PC2 it will say I am PC1. Check. Source IP 10.1.1. Whose IP? PC1's IP. Who is the destination? PC2. What is the MAC address? 11 router IP. I mean router MAC and destination means this packet will not even come here. Go back. Okay. And now the next ARP response. I mean the next ICMP packet. This will travel because now everyone has the MAC addresses for everyone. Now there will be no problem in the communication. Is that clear? Now, how do you see whether or not the router is acting as a proxy? So if you give the command show ARP, if you check, this is self, this is PC2. What is the MAC address for PC2? Correct? Router. And if I ping the router IP, what should be the MAC address? Same. Do ping. This entry and this entry. Same MAC address. 2 IPs with same MAC address. That means your router is acting as a proxy. Okay. Is that clear? So proxy ARP concept is clear. That whenever you want to communicate with a different network, your router in between will be acting as a proxy. Okay. This is clear. Any doubt in the proxy ARP? Default gateway or proxy ARP?
So 2 types are there, no? If it is communicating with PC.
Hmm.
So default gateway will be.
See, in case of PC, what happens? We send everything to the default gateway. But still, if the packets are generated for destination, IP, source IP and destination IP, they will remain source and destination only. Only the MAC address is making the difference. Why? Because what is the task of your ARP? Bringing the MAC address, right? So there also a router is acting as a proxy ARP, but sometimes it is hard to understand with the PCs. That okay, you will say, okay, it is generating for the default gateway, ARP is generated for the default gateway. But when the actual packet is traveling, what is happening? The destination MAC address will still remain the router's MAC address. Okay. These are just two cases for the explanation purpose. Otherwise, proxy ARP is what? Your router will act as a proxy, and for each and every destination, it will give its own MAC address, not just one destination. If I have 10 different networks, for all 10 different networks, router will give its own MAC address. That is what is your proxy ARP. Is that clear?
So what was that? It was showing type ARPA ARP. What does that mean?
Type ARP,
In this command, do show up.
do show ARP. Okay.
Type
ARPA, Advanced Research Project Agency. This is the agency who developed the first networks. Okay. These are the agencies. The first network was designed by the ARPANET. Okay. Advanced Research Project Agency network for the Department of Defense. And from there onwards, everything is coming up. Okay.